Today we are discussing about the local interconnect network, or LIN. That is, we know many of the mechanical components in the automotive sector have replaced their counterparts with mechatronical systems. We know mechanical power window is there, power steering is there. For all these things, wirings are required. A lot of wires are needed to connect these components, that is these mechatronical systems. So to reduce the amount of the wires and to handle communication between these systems, many car manufacturers have created different bus systems that are incompatible with each other. That is, it should be compatible with different systems. In order to have a standard bus, in order to have a standard sub bus, car manufacturers in the Europe have formed a consortium to define new communication standard for the automotive sector. So a new bus standard known as LIN bus was invented to be used in simple switching applications. That is, it is used in simple switching applications, not like CAN. It is used in car seat. Suppose car seat adjustment, door lock, sunroof, rain sensors, mirror adjustment. For all these applications, we are using LIN. But for other applications, suppose ABS and again airbag, that kind of applications, still we are using CAN itself. LIN bus is a bus subsystem based on a serial communication protocol. That is, our CAN is also a serial communication protocol. The bus is a single master multiple slave bus that uses single wire to transmit data. Unlike CAN uses a twisted pair wire for communication of data, but here we are using a single wire to transmit the data. And again, to reduce cost, components can be driven without crystal or ceramic resonators. That is, there can be for in the case of CAN, we are using microcontroller, and each microcontroller is driven by crystal or ceramic oscillators. But here we can use RC oscillators or any kind of resonators in the LIN, and time synchronization permits the correct transmission and reception of data. And the LIN system is based on a UART hardware. In almost all microcontrollers, this hardware is there. You might have studied these things in the microcontroller UART hardware interface that is common to most microcontrollers. That is, it is most common to most microcontrollers. The bus detects defective nodes in the networks. If some nodes are defective, that will be detected by the network itself, and data checksum and parity check guarantee safety and error detection. So here also error detection and correction is there. So here also we can have we can see the structure of a LIN architecture. So there is a master and so many slaves, up to 15 slaves we can connect in a LIN architecture. So there is a LIN bus. This is a single wired connection, The other wire is the ground. Ground means normally body of the vehicle can be treated as the ground line. So there is only one line communication, and again this master may be connected to the CAN bus. So this is the architecture of a LIN structure, and in the LIN concept, it uses a single master and multiple slave. Only one master is there and multiple slaves are there. In the case of CAN, you might have seen there will be a number of nodes will be there. Each node can initiate communication, but here only master can initiate the communication. Only the master is able to initiate communication. Here only the master is able to initiate the communication. That is the main difference between CAN and LIN. And a LIN frame consists of a header and a response part. in the case of CAN, we have seen there will be an address field. Based on that data in that address, we can select the node. So there will be some priority, but here a lin frame consists of a header and a response part. In the data means that a lin frame consists of a header and a response part, and to initiate a communication with a slave, that is, to initiate a communication with a slave, master sends the header part. Header part will be sent by the master, and if the master wants to send data to the slave, it goes on sending the response part. That is, there will be a header part and response part. So if the master wants to send data to the slave, it will send both header as well as response part. If the master requests data from the slave, slave sends the response part. That is, if the master is required data from the slave, the response part is filled by the slave. That is the difference. If the data is sending by master, masters fill the response part. So here this is the master. Here there is a slave 1 and there is a slave 2. So here you can see this is the lin frame. So this is the header, and this is the response. So this is a lin frame. So in this a header part and a response part is there. So here this is the master, this is the slave 1 corresponding to this color, and the corresponding to this color, this is the slave 2. So here slave 2 is responding. But the communication from the master will go to slave 1 as well as to slave 2, and as the header is intended for the slave 2, the response will come from the slave 2. So similarly, similar to our CAN, almost all the slaves will receive the same data. If the master sends the data, the slave or the slaves will get the same data. That is, the direct communication between slave is not possible. That is, here in the previous slide, communication between slave 1 and slave 2 is not possible. It is possible, but slave 2 cannot initiate a communication to slave 1. So, but as all nodes always listen to the bus, that is, this is the lin bus. So slave 1 and slave 2 is listen to this bus. So but as all nodes always listen to the bus, a master request can be used to handle slave to slave communication. That is, suppose it is slave 2 wants to communicate with the slave 1, for that also a request from the master is required. A request from the master has to do that communication between slave 1 and slave 2. That is, if slave 2 wants to send wants to communicate between slave 1 and slave 2, slave 2 has to initially acknowledge that slave 2 has to initially inform that thing to the master, and the master has to initiate that communication between slave 1 and slave 2. And the header contains, so this is the header, the header contains identifier which identifies the lin frame and the data it contains, and different nodes may receive the same frame data. That is, all the nodes, this is node, slave is actually a node, all these nodes receive the same data, that is similar to CAN itself. And the response part consists mainly of data of selectable length, that is 1 to 8 bytes. That is, this is the response part. So response part, the length of the response part may change. It may change between 1 byte and 8 bytes, and the lin protocol is time trigger oriented. That is, time trigger oriented means the master will continuously sends data at regular intervals. That is, the master periodically sends the same sequence of lean frames. That is, it is periodically sends the same sequence of lean frames. Each sequence, the master and slaves update the data they send and receive. That is, in each sequence, the master and slaves update the data. The sequence sent by the master may change depending upon application events. That is, the data sent by the master may change depending upon the application. And for example, the slave is if the slave is a sensor measuring a analog value, that is, if the slave is measuring, if it is a sensor measuring some analog value, suppose the speed of some instrument in the vehicle, or suppose the position of the mirror, which is communicated to the master via LIN. That is, the analog value is sent to the master via LIN. The slave continuously measures its analog inputs independently from the LIN communication. That is, the slave continuously measures the inputs, and in response to the master request periodically, that is, master is sending the request periodically, the slave sends the up to date last measured value. Up to date, or that is, always the slave will send the data to the master. That is, the analog input value will be sent to the master. That is, if it is the position of the mirror, that will be correctly sent to the master. So here the slave 2 is sensing the suppose the position of the mirror. It is having some analog value, that is 25, it may be 25, and it is sending to the master continuously. And if it is changing, suppose after some time there may be a change, so that value will be sent to the master. In order to achieve a good level of security, different mechanisms exist, like parity bits, that is, parity bits for error detection and corrects on the identifier, or checksum on data bits. One important feature of the protocol is to enable the slave microcontroller units, that is, there will be master and there will be a slave, to run with low cost oscillators. That is, here in the case of slave, we will not use crystal oscillators. Instead of that, we will use some RC oscillators, and provided its accuracy is less than plus or minus accuracy is better than plus or minus 15%. Accuracy should be better. So, accuracy should be better than plus or minus 15%. If it is crystal oscillator, the accuracy is very better, but in the case of this LIN, to reduce cost, we can have we can use RC oscillator instead of crystal oscillator in the slave, but in the master we will use crystal oscillator itself, but in the slave devices we can use RC oscillator. And for this purpose, header contains, there will be a sync field byte consisting of a constant 55 with a value 55. For synchronization, we will use this sync byte with value 55. So, we will get a particular number format. So, because of that number format, this byte, that is the previous byte, enables the slave to measure the master bit time and to synchronize with its clock, that is, the slave clock as well as master clock will be synchronized with the bytes in that synchronization byte, that is, here there will be a value. So, this byte can be used to synchronize the master clock as well as the slave clock. And in order to obtain very low power consumption, the master is able to send a sleep frame. That is, if some devices are not required, if some suppose we want to turn off some device, some device can be turned off. Suppose if the mirror can be turned off, once it is set, we can turn it off. So, in order to obtain very low power consumption, the master is able to send a sleep frame. So that mirror, the slave corresponding to that mirror will be turned off, and any node can go into low power mode. That is, any node means mirror, again window, again seat mechanism, all these can go to low power mode. To wake up the network, any node can send a wake up call to the master. That is, if we want to make use of some node, we have to send a wake up message. Similar to our CAN node, a LIN node also consists of a microcontroller for handling the LIN protocol, and there will be a LIN transceiver. We have seen a CAN transceiver. So, similar to CAN transceiver, there is a LIN transceiver for interfacing digital part and physical line. So, for interfacing, here in the case of CAN, we have seen a bus which is working in differential mode, a twisted pair bus which is working in differential mode. But here we are not using a differential line, we are using a single line for the LIN architecture, and the other line will be the body, that is the ground, the body of the vehicle. And here this is a LIN bus architecture. This is the master, the slave, different slaves are there, up to 15 slave can be connected, and here this is the contents of the slave. Here also there will be a microcontroller, but here we may not require a crystal oscillator for this microcontroller. We can use even an RC oscillator for this microcontroller, and again there will be a digital part will be there, and to convert that digital part to a serial data, we will use a LIN transceiver, not CAN transceiver. Here this is LIN transceiver, and here there will be a UART also will be there. From that, for a universal serial communication, we are using that UART. So, we are using that UART. From that UART, we are connecting to the transceiver, and it is connected to the LIN bus. Now we can see the key features of the LIN bus. It is very low speed bus, that is only up to 20 kilobytes per second, but can be used up to 1 megabytes per second, and there is a single master multiple slave network, that is here only one master and multiple slave network. No arbitration is required for LIN messages, that is there in the case of CAN there is an arbitration, bus arbitration is there. We are using that, we have seen that how one node assessing the CAN bus. Here such an arbitration is not there in the case of LIN messages. Guaranteed message latency times, there will be message latency will be there, but there will be a maximum value, and it is extensively used for sub networks, that is it will not be used for main networks. That is, main network means it is ABS, brake system, then again airbag, all these things are the main network that is connected to our CAN itself, but the other systems, that is mirror, seat mechanism, window, all these things can be used with LIN bus. And the devices connected to the LIN bus is these are the devices that are connected to the LIN bus. One is the side mirror, the window lift, that is the window glass, then door switches, seat switches, heat ventilation and air condition. Heat ventilation, that is even if there is some problem with that is not a main part of our vehicle, then sunroof controller, then ambient lighting and radio navigation switches, all these are connected to the LIN bus. So, these are not the main part of the vehicle. So, even if there is some errors that can be adjustable. So, that is why we are using the LIN bus to these devices, and this is the LIN hardware features. This is a low cost silicon implementation based on UART interface, that is the microcontroller is there, and almost all microcontroller will have an UART, and low cost single wire implementation, that is a single wire implementation system, that is there is a B plus. This is B plus means the supply voltage to the CAN transceiver, sorry, LIN transceiver, supply voltage to the LIN transceiver. This will come from the battery, and there is a ground. Ground means normally the body of the vehicle, and this is the LIN bus. This is the LIN bus. It is connected to all the nodes LIN bus. So, it is a single wire communication, and no hardware LIN controller is required. So, there is no hardware LIN controller is there. No crystal required for slave nodes. Crystal onnulla. We can, there is no crystals are there in the slave nodes. Now, we can compare the LIN versus CAN, and the LIN is lower up to 20 kilobits per second for LIN, but CAN is 1 Mbps, that is 1 megabits per second. LIN has only one, that is the speed of LIN is very small compared to the speed of CAN, and the LIN has only one node that can start message transmission and no arbitration. That is LIN has only one node, that is the master node that can start message, but in the case of CAN any node can start transmission, and LIN protocol is handled by software drivers. CAN is handled by hardware controllers, that is LIN is normally handled by software drivers, but CAN is handled by hardware controller. There is a CAN controller chip is there, and the LIN has dedicated schedule tables which control bus utilization. That is LIN is actually using some dedicated schedule tables, means normally at regular intervals the master will send the messages in the bus. So, this is the typical network of LIN. So, there is a master, and the master is connected to one line. This is the supply voltage. Normally all devices require a supply voltage. So, this is the supply voltage to the master, and this is the ground. So, all the devices will be have supply voltage and ground, and there is a LIN. There is a LIN connection between all the slaves and master. So, this is the LIN bus. So, this is the connection between LIN master and all the slaves. Up to 15 slaves we can connect. And we have seen there is a LIN frame, that is it is a message. This is a message. The LIN is a master slave protocol that we have seen. Master controls all communications in the LIN. So, this is the LIN frame. This is the LIN frame. This is the master header. This is the master header, and this is the slave response. This can be a slave response as well as a message from the master itself. Master itself can also send the response, or slave also can send the response. So, this can be filled by any one of the slaves or the master. This is given by the master only. And here you can see a LIN frame example. Here this is the master header. This is the LIN bus, a master header, and here also a master header. But the data from the slave 1 is of lesser duration. The number of bits are lesser in the response field, but the response from the slave 2 consists of more data. The data field will be lengthier in the case of the slave 2. So, that will depends upon the slave. It can have lesser data or more data. Here the slave 2 fills the data response, and here slave 1 fills the response. Again master itself can also send the response. See another example. There is a master node master sends the node, this is the header, master header, then slave 1 will give the data after master header, slave 1 the data, and here after the master header slave 2 sends the data, and here after the third one, after the third header, master itself is sending the data. That is, here the response is in this area, the response is filled by the slave 1, in this area response is filled by the slave 2, and here in this area the master itself fills the data. So here consider the case, here the master header, after the master header, the first master header, no slaves are responding, no slaves in this case neither slave 1 nor slave 2 responded in this area, or master is not giving any data. But after the second header, master header, slave 2 responded, and after the third header, the master itself responded to the response field. Consider another case. So here in this case, after the first master header, slave 2 is responded, and after the second master header, again slave 2 is responded, and after the third header, the master itself is giving the response field. So here the response field is filled by the slave 2, and here also the response field is filled by the slave 2. And consider another case, after the first master header, slave 1 as well as slave 2 is responding. After the first header, slave 1 and slave 2 is responded, and there will be a data collision will occur, and after the second responder, after the second header, slave 1 is responding, and after the third header, slave 2 is responding. Here the master is not responding, or master is not giving a response in this field. Here in this response field, both slave 1 and slave 2 is responding. So there is a data collision occurs. Here slave 1 is responding, in this response field slave 1 is responding, and in this field slave 2 is responding. And here we can see how to sync the master and the slave. That is, we have previously seen hex value 55 will be sent by the master, that is used to sync the master and slave. So depending upon that bit, hex value 655, the slave can sync with the master. So there is a break of data will be there, and after that, so this is the break of data, then there is a sync byte. So the sync byte, this will be sent, and again there is, after that the identifier will be sent. And here comparing with the CAN, the LSB will be sent initially, but in the case of CAN we are sending the MSB first, that we have seen earlier. MSB will be sent first. So based on that we are assigning the we are assigning the priority to the nodes, but here the LSB will be sent first. And here so there, if there is a message break, there will be a synchronization field will be there, and after that the ID field will be the message identifier, that is the identifier will be master header, similar to the master header will be sent. So our lin frame will have a structure like this. The lin slave could fill in 0 to 8 data bytes. This is the slave, it can be from 0 to 8 data bytes, and this is the master header. It will consist of the sync as well as the ID and the break field. All these things will be there in the in the lin data frame. In the lin data frame, there will be a master header and the slave response. Slave response can be up to 8 bytes, and here it can be in the master header. It will consist of the ID and the sync data and the break of data also.